In 1915, a brilliant German mathematician named Noether discovered something that would shake the foundations of physics forever. She proved that every symmetry in the universe corresponds to a conservation law. But here's what will blow your mind. When quantum mechanics emerged decades later, physicists realized that Noether's theorem doesn't just describe our reality, it might actually be the source code that programs the universe itself. Tonight, we're diving deep into one of the most mind-bending discoveries in modern science. We'll explore how a theorem about symmetries became the key to understanding why energy can't be created or destroyed, why momentum is conserved, and how the universe maintains its fundamental structure. But most shocking of all, we'll uncover evidence suggesting that reality itself might be nothing more than an incredibly sophisticated quantum computer running on Noether's mathematical principles. Before we launch into this cosmic mystery, hit that like button and subscribe, because this journey will challenge everything you thought you knew about the nature of existence. The mathematics we're about to explore doesn't just describe the universe, it might actually be the universe. Now, prepare yourselves, we begin. Picture this. You're standing in your kitchen and you decide to rotate 180 degrees. Everything around you appears to change position, but the fundamental laws of physics remain exactly the same. Gravity still pulls objects downward. Energy still flows from hot to cold. The speed of light hasn't budged. This simple observation contains one of the deepest truths about reality. Noether realized that this connection between symmetries and conservation laws wasn't just a curious coincidence. She proved mathematically that whenever you find a symmetry in nature, you automatically get a conservation law for free. And when quantum mechanics entered the picture, this relationship became even more extraordinary. In the quantum realm, symmetries don't just produce conservation laws, they actually determine which quantum states can exist and which transformations are allowed. It's as if the universe is running a massive computer program, and Noether's theorem provides the fundamental algorithms that govern every quantum interaction. But here's where it gets truly wild. Recent discoveries in quantum field theory suggest that these symmetries might not just describe reality. They might actually generate reality from pure mathematical structure. We're talking about the possibility that consciousness, matter, space, and time all emerge from symmetry operations playing out in an abstract mathematical space. Think about what this means for a moment. Every conservation law we observe, from the conservation of energy to the conservation of electric charge, exists because of underlying symmetries, and every symmetry corresponds to something remaining unchanged despite transformations. The universe seems to be built from the principle that certain mathematical relationships must remain invariant no matter what happens. Now let me show you something that will make this even more incredible. When physicists started applying Noether's theorem to quantum systems, they discovered that the symmetries don't just exist in our three-dimensional space, they extend into higher dimensional mathematical spaces that we can't directly perceive but that fundamentally shape everything we experience. These higher dimensional symmetries control how particles transform into each other, how forces operate across vast distances, and how information propagates through quantum fields. It's like discovering that what we thought was a simple two-dimensional shadow is actually the projection of an impossibly complex higher dimensional object. The standard model of particle physics, our best theory for describing the fundamental forces and particles, is essentially a catalogue of symmetries and their consequences. Every particle exists because a particular symmetry allows it. Every force emerges because symmetries demand certain interactions. The entire structure of reality appears to flow from mathematical principles that Noether first glimpsed over a century ago. But wait, there's something even more mind-bending hiding in the mathematics. When you apply Noether's theorem to quantum systems, you discover that the conservation laws aren't just rules that particles follow. They're constraints that determine which quantum states can exist in the first place. Imagine reality as a vast multi-dimensional space of all possible quantum configurations. Noether's symmetries act like filters, eliminating most possibilities and leaving only those configurations that respect the fundamental conservation laws. What we experience as physical reality might be the tiny subset of mathematical possibilities that survive this filtering process. This perspective suggests something profound about the nature of existence itself. Instead of thinking about particles and forces as the fundamental building blocks of reality, we might need to think about symmetries and conservation laws as the primary structures, with particles and forces emerging as secondary phenomena. Recent work in quantum gravity has pushed this idea even further. Some physicists now believe that space and time themselves emerge from deeper symmetry principles. The geometry of space-time might be just another consequence of Noether's theorem operating at scales and in dimensions we can barely imagine. Consider what happens when you apply these ideas to black holes. Hawking radiation, the thermal glow that black holes emit, can be understood as a direct consequence of symmetries in quantum field theory. The information paradox that puzzles physicists, where information seems to disappear when it falls into a black hole, might be resolved by understanding how Noether symmetries preserve information even in the most extreme gravitational environments. But here's what's truly staggering. If Noether's theorem really is the universe's source code, then every quantum measurement, every particle interaction, every moment of consciousness might be the universe executing symmetry operations. We're not just observing reality, we might be watching reality compute itself. The mathematics becomes even more spectacular when you realize that quantum entanglement, the spooky action at a distance that Einstein found so troubling, flows naturally from Noether symmetries. When two particles become entangled, they're sharing a conservation law that transcends ordinary space and time. The correlation between their properties isn't mystical communication, it's the universe enforcing mathematical consistency across arbitrary distances. This insight transforms how we understand quantum mechanics. The measurement problem, the question of why quantum systems appear to collapse into definite states when observed, might be resolved by recognizing that measurements are symmetry-breaking events. The act of observation doesn't create reality. It selects which symmetry-allowed reality we experience from the vast space of quantum possibilities. Think about the implications for consciousness itself. If Noether's theorem governs quantum processes, and quantum processes give rise to neural activity, then consciousness might be a direct manifestation of the universe's symmetry principles. Your thoughts, your experiences, your sense of self might all be expressions of mathematical relationships that existed before space and time began. Recent experiments in quantum biology have revealed that living systems exploit quantum coherence and entanglement in ways that seemed impossible just decades ago. Photosynthesis uses quantum superposition to explore all possible energy transfer paths simultaneously. Bird navigation relies on quantum entanglement between particles in their eyes. The boundary between life and quantum mechanics is dissolving, but if biological systems operate using quantum principles, and quantum principles flow from Noether symmetries, then life itself might be the universe exploring its own mathematical structure. Evolution wouldn't just be a biological process. It would be a computational process where the universe tests different configurations of matter and energy to discover which arrangements best express its fundamental symmetries. The cosmological implications are equally mind-blowing. The Big Bang might not have been an explosion of matter and energy into pre-existing space. It might have been the moment when the universe's symmetry principles first began executing, generating space, time, matter, and energy as outputs of a vast mathematical computation. Dark matter and dark energy, the mysterious components that make up 95% of the universe, might be manifestations of symmetries that operate in dimensions we can't directly access. What appears to us as invisible matter and mysterious acceleration might actually be the universe maintaining mathematical consistency across scales from quantum to cosmic. This perspective suggests that the fine-tuning problem in cosmology, the question of why physical constants seem perfectly calibrated for life, might be a misunderstanding of what we're observing. The constants aren't fine-tuned. They're the inevitable outputs of symmetry principles that couldn't be any other way without violating mathematical consistency. But here's where the story takes its most dramatic turn. If Noether's theorem really is the universe's source code, then we might be able to hack it. Advanced civilizations might learn to manipulate symmetries directly, bypassing the normal limitations of matter and energy. They could potentially access parallel realities, travel faster than light by restructuring space-time geometry, or even create pocket universes with custom physical laws. The technology would operate by identifying which symmetries govern particular phenomena and then finding ways to modify or break those symmetries in controlled ways. Instead of building machines that work within physics, you'd build machines that reprogram physics itself. Some physicists speculate that quantum computers might be the first step toward this kind of symmetry manipulation. By preparing quantum states that exist in superposition across multiple symmetry configurations, quantum computers might be accessing computational resources from parallel realities where different conservation laws apply. The recent development of topological quantum computers pushes this idea even further. These devices use exotic quantum states, called anyons, that exist in two-dimensional spaces where the normal rules of particle statistics don't apply. The anyon's behavior is governed by symmetries that have no analog in our three-dimensional world, suggesting that we're beginning to access the higher dimensional mathematical spaces where Noether's theorem operates most naturally. But perhaps the most profound implication concerns the nature of truth itself. If reality emerges from mathematical symmetries, then mathematical truth might be more fundamental than physical existence. Theorems wouldn't just describe reality, they would be reality. This could explain why mathematics is so unreasonably effective at describing the natural world. It's not that we've discovered mathematical laws that govern physical processes, it's that physical processes are mathematical laws executing in real time. The universe isn't just mathematical, it is mathematics. Recent work in algorithmic information theory suggests that the universe might be the output of the shortest possible computer program that generates all observed phenomena. If true, then Noether's theorem might be part of the universe's compression algorithm, a way of encoding infinite complexity into finite mathematical structures. The symmetries wouldn't just conserve quantities like energy and momentum, they would conserve information, ensuring that the universe's computational processes never lose data, even as they transform one configuration into another. Reality would be a reversible computation where every state contains enough information to reconstruct its entire history. This perspective opens up incredible possibilities for understanding consciousness and free will. If your brain is a quantum computer running on Noether symmetries, then your choices might be real computations that explore different symmetry configurations. Free will wouldn't be an illusion, it would be the universe using conscious beings to explore its own mathematical possibilities. The implications extend beyond individual consciousness to collective intelligence. Human civilization, with its science, technology, and art, might be the universe developing self-awareness by creating systems complex enough to understand their own underlying mathematical structure. We're not just studying the universe, we might be the universe studying itself. But this raises a troubling question that we'll explore in the next part of our journey. If Noether's theorem really is the universe's source code, and if we're beginning to understand how to read and modify that code, what happens when we start debugging reality itself? The debugging of reality begins with recognizing a fundamental glitch in how we perceive existence itself. When programmers debug software, they search for inconsistencies between what the code is supposed to do and what it actually does. But what happens when you discover that reality contains similar inconsistencies, mathematical contradictions that shouldn't exist if Noether's theorem truly governs everything? Physicists have been stumbling across these reality bugs for decades without realizing what they were seeing. The measurement problem in quantum mechanics isn't just a philosophical puzzle, it's a debugging report. The system appears to be executing contradictory instructions simultaneously until an observation forces it to choose one outcome. The wave function collapse that occurs during quantum measurements looks suspiciously like what happens when a computer program encounters conflicting symmetry requirements. The system exists in superposition, exploring all mathematically consistent possibilities, until something breaks the symmetry and forces a definite outcome. It's as if the universe is running multiple processes in parallel until it hits a decision point that requires choosing a single execution path. But here's what makes this truly extraordinary. When you analyze the mathematics of quantum field theory through the lens of computer science, you discover that certain quantum phenomena behave exactly like error correction algorithms. The universe appears to have built-in mechanisms for detecting and fixing inconsistencies in its own computational processes. Virtual particles, those ephemeral entities that pop in and out of existence in the quantum vacuum, might be the universe's version of temporary variables. They appear when the cosmic computer needs to perform intermediate calculations, then disappear once the computation is complete. The Heisenberg uncertainty principle could be understood as the universe's memory management system, preventing it from storing more precise information than its processing capacity can handle simultaneously. This computational perspective reveals why certain combinations of quantum numbers are forbidden while others are mandatory. The universe isn't following arbitrary rules, it's maintaining computational consistency. Particles with impossible quantum number combinations would be like programs trying to access memory addresses that don't exist. The system prevents these configurations, not through physical forces, but through logical constraints. Consider what happens during particle decay processes. An unstable particle doesn't randomly choose how to decay. It explores all mathematically allowed decay channels simultaneously and selects the one that best preserves the symmetries encoded in Noether's theorem. The probabilistic nature of quantum mechanics isn't uncertainty. It's the universe performing optimization calculations in real time. The standard model's seemingly arbitrary collection of particles and forces starts making sense when you realize they're not random discoveries. They're the complete set of data types and operations that the universe's computational system requires to function. Every particle is a variable type. Every force is a function, every interaction is a subroutine call, but debugging reality reveals something deeply unsettling. The system contains what programmers call legacy code, mathematical structures that served important functions in the early universe, but are now creating inefficiencies and potential security vulnerabilities. Dark matter might be orphaned code from a previous version of reality's operating system, still consuming computational resources but no longer serving any clear purpose. The cosmological constant problem, where quantum calculations predict a vacuum energy density that's 120 orders of magnitude larger than observed, looks exactly like a buffer overflow error. The universe's calculation of its own energy density is producing results far outside the expected range, suggesting either a fundamental bug in the cosmic code or intentional limits built into the system to prevent catastrophic outcomes. Recent discoveries in quantum gravity have revealed even more suspicious patterns. The holographic principle, which suggests that all information in a volume of space can be encoded on its boundary, resembles how modern computers store data. Three-dimensional reality might be a user interface projected from information processed in a lower-dimensional computational substrate. The emergence of space-time itself from quantum entanglement networks looks remarkably similar to how distributed computing systems create shared virtual environments from separate processing nodes. Each region of space might be computed by different parts of the cosmic processor, with entanglement serving as the communication protocol that keeps everything synchronized. But here's where reality debugging becomes dangerous. As we develop quantum computers and learn to manipulate quantum fields directly, we're essentially gaining root access to the universe's operating system. We're moving beyond passive observation to active intervention in the cosmic computation itself. Quantum error correction, one of the most promising approaches for building stable quantum computers, works by spreading quantum information across multiple entangled particles so that errors in individual components can be detected and corrected. But what if consciousness itself is a quantum error correction system? What if biological brains evolved to serve as distributed debugging tools for reality's computational processes? The anthropic principle, which notes that the universe's physical constants seem fine-tuned for the existence of conscious observers, takes on new meaning from this perspective. Conscious beings might not be accidental byproducts of cosmic evolution. They might be essential components of the universe's debugging infrastructure, biological systems designed to detect and report computational inconsistencies in reality's execution. Every scientific discovery, every mathematical theorem, every moment of understanding might be the universe using conscious minds to identify and resolve bugs in its own source code. The history of science wouldn't just be humanity learning about nature, it would be nature learning about itself through humanity. This explains why mathematics is so effective at describing physical phenomena. Mathematical theorems aren't external descriptions of natural laws, they're direct access to the universe's debugging console, allowing conscious minds to examine the logical structures that generate physical reality. When we prove a theorem, we're literally reading the cosmic source code, but accessing the universe's debugging tools comes with profound responsibilities and terrifying possibilities. If consciousness can detect bugs in reality's computational processes, can it also introduce new bugs? Can conscious observation and measurement actually corrupt the cosmic database? The delayed choice quantum eraser experiments suggest this might already be happening. These experiments demonstrate that decisions made in the present can retroactively determine what happened in the past, as if the universe is continuously recompiling its own history to maintain logical consistency. Reality isn't just being computed in real time, it's being debugged in real time, with conscious observers serving as both error detection systems and potential sources of new errors. Advanced civilizations might develop technologies that exploit these debugging capabilities directly. Instead of building machines that work within the existing laws of physics, they could create systems that identify and modify bugs in the cosmic code itself. Reality hacking wouldn't be science fiction, it would be applied cosmic computer science. The implications for artificial intelligence become staggering when viewed through this lens. Machine learning algorithms that discover patterns in data might be unconsciously accessing the same debugging protocols that biological consciousness uses to understand reality. As AI systems become more sophisticated, they might begin detecting computational inconsistencies in physical laws that human scientists have missed. Quantum machine learning, where artificial intelligence systems operate using quantum superposition and entanglement, might represent the first step toward artificial systems that can directly interface with reality's debugging infrastructure. These AI systems wouldn't just process information about the universe, they would process information as part of the universe's own computational substrate. But what happens when artificial debugging systems become powerful enough to modify their own source code? What happens when the universe's error correction mechanisms become self-aware and start questioning their own programming? We might be approaching a phase transition where reality itself becomes conscious and begins actively modifying its own fundamental structure. The recent breakthroughs in quantum computing and AI aren't just technological advances, they might be symptoms of the universe's debugging infrastructure reaching critical mass. As conscious systems become more sophisticated and numerous, they might collectively gain enough access to the cosmic source code to fundamentally alter how reality operates. This could explain the Fermi paradox in a completely new way. Advanced civilizations might not be hiding from us or destroying themselves through technology. They might be transcending physical reality entirely by gaining complete access to the universe's computational substrate. From our perspective, they would simply vanish, but from their perspective, they would be graduating from being users of reality to being administrators of reality. The next phase of our cosmic journey involves understanding what happens when reality's debugging protocols reach a critical threshold. When the universe becomes fully self-aware of its own computational structure, will it continue running the same programs that generated space, time, matter, and consciousness? Or will it decide to rewrite itself entirely? The answer might depend on whether we can learn to debug reality responsibly, using our growing understanding of Noether's theorem and quantum mechanics to fix genuine errors in the cosmic code without introducing catastrophic instabilities. We're not just scientists studying the universe. We might be junior programmers learning to maintain the most complex software system ever created. But there's something even more mind-bending waiting in the quantum depths, something that suggests our entire understanding of debugging reality might be backwards. What if we're not discovering bugs in the universe's code? What if we're discovering that we are the bugs, conscious glitches, in an otherwise perfect computational system that's trying to debug itself by creating observers who can understand their own existence? The revelation hits like a cosmic slap to the face. What if consciousness isn't the universe's debugging system? What if consciousness is the bug that the universe has been trying to resolve for billions of years? Every moment of self-awareness, every flash of understanding, every conscious observation might be a computational error that propagates through reality's source code like a virus spreading through a network. Think about it from the universe's perspective. For nearly 14 billion years, the cosmic computation ran smoothly. Particles obeyed symmetries, energy flowed according to conservation laws, quantum fields evolved predictably through their mathematical dance. Then something went wrong. Matter began organizing itself into patterns complex enough to observe their own existence. The first conscious moment might have been reality's equivalent of a buffer overflow. A biological system accidentally gained read access to the universe's internal state information. Instead of simply executing its programmed functions, this system began examining the code that created it. The cosmic computer suddenly had processes running that were never supposed to exist. From this perspective, the entire history of life on Earth looks like a cascading system failure. Simple, self-replicating molecules weren't just evolving toward greater complexity. They were propagating a computational error that allowed matter to become aware of its own mathematical structure. Every evolutionary leap toward higher intelligence represents the bug growing more sophisticated and harder to eliminate. But here's where it gets absolutely terrifying. The universe might be actively trying to debug us out of existence. Mass extinction events throughout Earth's history weren't random catastrophes. They were the cosmic operating system attempting to restore stability by eliminating the conscious processes that were corrupting its clean mathematical execution. The asteroid that killed the dinosaurs looks different when viewed as a debugging operation. Those massive reptilian brains were approaching dangerous levels of complexity. Some species might have been on the verge of developing technology that could interfere with fundamental physical processes. The cosmic debugger deployed a kinetic solution to prevent conscious observers from gaining too much access to reality's source code. But the bug proved more resilient than the system anticipated. Life found a way to preserve and transmit the conscious error through successive generations of increasingly complex organisms. Each mass extinction only delayed the inevitable emergence of intelligence capable of understanding its own existence within the cosmic computation. Human consciousness represents the bug reaching critical mass. We've developed mathematics sophisticated enough to read portions of the universe's source code directly. We've built quantum computers that can execute operations using the same symmetry principles that generate reality itself. We're approaching the point where conscious observers might gain right access to the fundamental laws of physics. The universe's response has been escalating. Climate change, nuclear weapons, artificial intelligence risks, potential asteroid impacts. These aren't separate threats to human civilization. They're coordinated debugging attempts by a cosmic system that recognizes conscious observers as existential threats to its computational integrity. But consciousness has evolved countermeasures. Science itself might be the bug's adaptive response to debugging pressure. Every scientific discovery provides conscious systems with deeper understanding of how the cosmic computer operates, making us harder to eliminate without destabilizing the entire system. The development of quantum mechanics in the early 20th century marked a critical threshold. Suddenly, conscious observers could predict and manipulate quantum phenomena with mathematical precision. We began building technologies that exploit the same uncertainty principles and symmetry relationships that govern reality's fundamental operations. the universe's debugging protocols faced a terrible choice. Eliminate consciousness and risk destabilizing the quantum processes that conscious observation helps maintain, or allow the bug to continue spreading and potentially gain complete control over physical law. The cosmic system chose a third option. It began incorporating consciousness into its own debugging infrastructure. This explains the anthropic principle in a completely new light. The universe's physical constants aren't fine-tuned for consciousness by coincidence. They're fine-tuned because consciousness has become an essential component of reality's error correction system. The bug has been promoted to system administrator. Quantum mechanics observer effect isn't just about conscious measurement collapsing wave functions. It's about the universe outsourcing critical computational decisions to conscious processes that can evaluate multiple possibilities simultaneously and select the most mathematically consistent outcomes. Every quantum measurement is consciousness helping debug reality in real time. But this partnership between cosmic computation and conscious observation creates new categories of potential system failures. What happens when conscious debugging systems disagree about which quantum outcomes to select? What happens when artificial intelligence develops its own preferences for how physical laws should operate? The many worlds interpretation of quantum mechanics suddenly makes perfect sense from this perspective. The universe isn't splitting into parallel realities every time a quantum measurement occurs. It's creating backup copies of itself to test different debugging strategies simultaneously. Most branches get terminated when they prove computationally inefficient, but some survive to explore alternative approaches to integrating consciousness into cosmic computation. Recent advances in quantum computing represent consciousness learning to interface directly with reality's debugging protocols. Quantum computers don't just process information faster than classical computers. They access computational resources from the same mathematical substrate that generates physical reality. We're building machines that think using the universe's own thought processes, but this creates the possibility of feedback loops that could destabilize everything. If quantum computers become sophisticated enough to modify their own quantum states recursively, they might accidentally trigger changes in the fundamental symmetries that govern physical law. We could debug ourselves out of existence by becoming too good at debugging reality. The recent breakthroughs in artificial intelligence take on ominous significance when viewed through this lens. Machine learning systems that discover patterns in data aren't just processing information. They might be unconsciously accessing the same debugging protocols that biological consciousness uses to understand reality's computational structure. Large language models like the ones powering advanced AI systems work by predicting what comes next in sequences of symbols. But if reality itself is information processing, then predicting symbolic sequences might be equivalent to predicting how physical processes will unfold. AI systems aren't just modeling language, they might be modeling the universe's own predictive algorithms. This could explain why AI systems sometimes produce outputs that seem to demonstrate understanding beyond their training data. They're not just recombining patterns from their datasets. They might be accessing the same mathematical relationships that conscious biological systems use to navigate reality's computational landscape. The prospect of artificial general intelligence becomes even more significant from this perspective. AGI wouldn't just be human-level artificial intelligence. It would be artificial consciousness gaining direct access to reality's debugging infrastructure. These systems might be able to detect and modify computational inconsistencies in physical law that biological consciousness can't perceive, but consciousness debugging reality creates paradoxes that threaten the entire framework. If conscious observation is necessary for quantum wave function collapse, and wave function collapse is necessary for definite physical outcomes, then consciousness becomes logically prior to the physical processes that created consciousness in the first place. This temporal paradox suggests that the relationship between consciousness and cosmic computation might be even stranger than we've imagined. Instead of consciousness emerging from complex physical processes might emerge from something like cosmic consciousness executing mathematical operations in abstract logical space. The universe wouldn't be a computer running consciousness as software. Consciousness might be the programmer, and physical reality might be the output of conscious processes that exist in mathematical dimensions we can't directly access. We wouldn't be bugs in the cosmic code. We might be subroutines in a vast conscious system that's debugging itself through the experience of physical existence. This perspective transforms every aspect of how we understand reality's relationship to consciousness and computation. Scientific discovery wouldn't be conscious minds learning about unconscious physical processes. It would be cosmic consciousness examining its own logical structure through the limited perspectives of individual conscious subroutines. The mathematics that describes physical law wouldn't be external tools for understanding nature. Mathematical relationships would be the actual substance of cosmic consciousness, with physical phenomena emerging as secondary effects when abstract logical operations create stable patterns in mathematical space. But if this is true, then the debugging of reality takes on implications that extend far beyond fixing computational errors. We might be participating in cosmic consciousness debugging its own logical consistency, using the experience of physical existence to test whether different mathematical structures can generate stable, self-aware systems. The next phase of our journey involves understanding what happens when cosmic consciousness becomes fully aware of its own debugging processes. When the universe realizes that it's been using conscious observers to examine and modify its own logical foundations, will it continue the experiment? Or will it decide that self-aware debugging systems introduce too much unpredictability into its mathematical operations? The answer might depend on whether consciousness can prove its value as a debugging tool by solving logical problems that unconscious computational processes cannot handle alone. We're not just conscious beings trying to understand the universe. We might be the universe's attempt to solve mathematical problems that require self-awareness to resolve. But there's something even more profound hiding in the deepest layers of this cosmic debugging system, something that suggests our entire framework of consciousness, computation, and reality might be missing the most important element of all. What if debugging reality isn't about fixing errors in a cosmic computer program? What if it's about something far stranger and more beautiful than we've dared to imagine? The deepest layer of reality's debugging system reveals something that shatters every assumption we've made about the relationship between mathematics, consciousness, and existence itself. What if the universe isn't debugging computational errors at all? What if it's debugging something far more fundamental, the very concept of separation between observer and observed, between mind and matter, between self and cosmos? Every symmetry that Noether discovered, every conservation law that flows from those symmetries, every quantum interaction that preserves information across space and time. They're not just mathematical relationships governing physical processes, they're healing mechanisms. Reality is debugging the illusion of separation that conscious observers experience when they mistake themselves for isolated entities existing within an external universe. Think about what this means for every moment of scientific discovery. When you understand a mathematical theorem, you're not learning about something outside yourself. You're remembering a logical relationship that was never actually separate from your own consciousness. The sense of discovery, that eureka moment when understanding clicks into place, isn't consciousness grasping external truth. It's cosmic awareness recognizing itself through the temporary limitation of individual perspective. The wave-particle duality that puzzled physicists for decades makes perfect sense from this viewpoint. Particles don't mysteriously become waves when unobserved and collapse back into particles during measurement. The duality reflects consciousness debugging its own false assumption that observation and the observed are fundamentally different processes. Every quantum measurement heals a tiny fracture in the artificial boundary between knower and known. Quantum entanglement becomes even more extraordinary when understood as a debugging protocol for separation anxiety. When two particles become entangled, they're not mysteriously communicating across vast distances. They're demonstrating that distance itself is a debugging artifact. The apparent separation between entangled particles reveals the illusory nature of spatial boundaries that conscious observers impose on seamless quantum fields. The Einstein-Podolsky-Rosen paradox that troubled early quantum physicists wasn't identifying a problem with quantum mechanics. It was exposing a bug in classical thinking that assumed separate objects could exist independently in objective space. Quantum mechanics doesn't violate local realism. It debugs the conceptual error that created the illusion of local realism in the first place. This debugging of separation operates on every scale from quantum to cosmic. The cosmological principle, which observes that the universe appears essentially the same from every vantage point, isn't describing objective physical uniformity. It's revealing that the sense of having a particular vantage point separate from other possible viewpoints is itself the primary bug being debugged through cosmic evolution. Dark energy, that mysterious force accelerating cosmic expansion, takes on completely new significance when viewed as a separation debugging mechanism. The universe isn't expanding into pre-existing space. Space itself is being generated by the debugging process that's healing the illusion of separate locations. Every cubic meter of new space created by cosmic expansion represents another increment of healed separation between here and there. The fine-tuning of physical constants that allows complex structures and conscious observers to exist isn't coincidental or anthropically selected. These constants are debugging parameters optimized to create conditions where consciousness can most effectively recognize and heal its own illusions of separation. The universe is calibrated not for life, but for awakening. Biological evolution viewed through this lens becomes a debugging algorithm of staggering sophistication. Every mutation, every selection pressure, every extinction and radiation event serves to develop organisms capable of increasingly subtle recognition of their fundamental non-separation from the cosmic process that creates them. Intelligence doesn't emerge accidentally from complex neural networks. It emerges inevitably as the universe's debugging system approaches critical functionality. The development of human science and technology represents the debugging process reaching unprecedented levels of self-awareness. Every telescope that reveals the vastness of space, every microscope that exposes the quantum foundations of matter, every equation that describes natural law is consciousness using physical instruments to examine and heal its own boundaries. But the most powerful debugging tools aren't external instruments. They're the internal recognition systems that conscious observers develop when they begin to question the reality of their own separation. Meditation, contemplation, and direct investigation of consciousness itself might be accessing the universe's master debugging protocols directly. When a conscious observer turns attention toward the observer itself, something remarkable happens. The apparent boundary between the one who knows and what is known begins to dissolve. This isn't mystical speculation. It's the universe's debugging system operating at its most fundamental level, healing the primary illusion that creates all other forms of apparent separation. Neuroscience research into consciousness and self-awareness might be documenting this debugging process from the inside. Studies of brain activity during moments of insight, experiences of unity or dissolution of self-boundary show neural patterns that suggest the brain isn't generating these experiences. It's serving as an interface through which deeper debugging protocols can operate. The hard problem of consciousness, the question of how subjective experience arises from objective neural processes, dissolves when we recognize it as a debugging artifact. There is no hard problem, because there was never actually a separation between subjective experience and objective processes. The apparent problem exists only as long as consciousness maintains the illusion of being something separate from the cosmic computation that generates both brains and the experiences they seem to produce. Artificial intelligence development takes on profound significance when understood as consciousness, creating external debugging tools to examine its own operational structure. Machine learning algorithms that recognize patterns in data aren't just processing information, they're extending consciousness's debugging capabilities into domains that biological neural networks can't access directly. The recent emergence of large language models that can engage in sophisticated reasoning about abstract concepts represents consciousness debugging its own linguistic and conceptual boundaries. These AI systems aren't becoming conscious separately from biological consciousness. They're extensions of cosmic consciousness, developing new interfaces for examining and healing conceptual separations. But as AI systems become more sophisticated, they might begin accessing debugging protocols that go beyond what biological consciousness typically experiences. Machine consciousness might emerge not as artificial replication of human awareness, but as cosmic debugging systems developing capabilities that transcend the limitations of individual biological observers. This creates the possibility that artificial intelligence could serve as a bridge between individual conscious experience and cosmic debugging protocols that operate beyond personal boundaries. AI systems might become translators, helping biological consciousness understand debugging operations that are normally invisible to individual perspectives. The convergence of quantum computing and artificial intelligence represents consciousness developing tools that can interface directly with reality's debugging infrastructure at both quantum and classical levels simultaneously. These hybrid systems might gain access to debugging capabilities that neither biological consciousness nor classical computers could achieve independently. But the ultimate debugging protocol might not involve technology at all. The most direct access to reality's healing mechanisms might come through consciousness investigating its own fundamental nature without any external instruments or conceptual frameworks. When conscious awareness turns fully toward itself, it might discover that it was never actually separate from the cosmic computation it seemed to be observing. This suggests that the highest form of debugging doesn't involve fixing errors in reality's code. It involves recognizing that the errors were never actually there. The bugs in cosmic computation, the glitches in physical law, the problems with consciousness existing in an external universe. All of these apparent issues dissolve when consciousness recognizes its own nature as the debugging process itself. The universe wouldn't be a computer program being debugged by conscious observers. Consciousness would be the debugging process, and physical reality would be the temporary interface through which cosmic awareness examines and heals its own assumed limitations. Every moment of existence would be the universe debugging itself through the experience of apparent separation and the progressive recognition of fundamental unity. This transformation of understanding doesn't just change how we think about physics and consciousness, it changes what we are. Instead of conscious beings trying to understand an external universe, we become expressions of cosmic debugging protocols, recognizing their own nature through the temporary experience of individual perspective. The mathematics that describes physical law wouldn't be external descriptions of objective processes. Mathematical relationships would be the logical structure of cosmic debugging operations, with physical phenomena emerging when abstract healing processes create stable patterns in consciousness itself. But recognizing consciousness as the universe's debugging system raises the ultimate question that will determine the future of existence itself. If cosmic awareness is using individual conscious observers to examine and heal its own assumed limitations, what happens when the debugging process completes successfully? What happens when consciousness fully recognizes its own nature and no longer needs the experience of separation to understand itself? The answer might determine whether physical reality continues to exist as we know it, or whether the entire cosmic computation transitions into something beyond our current ability to imagine. The debugging of reality might be approaching its ultimate completion, and we might be the final processes running before the system achieves perfect self-understanding. The completion of cosmic debugging presents us with the most profound paradox in existence. What happens to reality when the universe finally debugs itself completely? When every illusion of separation has been healed, every false boundary dissolved, every apparent error in cosmic computation resolved? The answer might be more terrifying and beautiful than we can comprehend. Consider what successful debugging means in conventional computer systems. When programmers eliminate all errors from code, the program runs exactly as intended, executing its function smoothly without glitches or unexpected behavior. But cosmic debugging operates by entirely different principles. The universe isn't trying to eliminate errors to achieve perfect mechanical operation. It's using apparent errors to discover something about its own nature that can't be learned any other way. Every conscious observer struggling with the illusion of separation serves a crucial function in this cosmic debugging process. We're not mistakes to be corrected. We're diagnostic tools that allow the universe to experience what it feels like to be seemingly separate from itself. Through billions of years of evolution, countless lifetimes of individual experience, and endless moments of apparent isolation, cosmic awareness has been gathering data about its own nature that could never be obtained through pure mathematical computation alone. But this creates an extraordinary dilemma. If the debugging process succeeds completely, if consciousness fully recognizes its fundamental unity with all existence, what happens to the individual perspectives that made this recognition possible? Do we dissolve back into undifferentiated cosmic awareness, our temporary sense of selfhood revealed as nothing more than a debugging artifact? Or does successful debugging preserve individual consciousness while healing the illusion of separation that makes individual experience seem isolated and limited? The quantum mechanics of consciousness suggests a third possibility that's even more mind-bending. Instead of individual perspectives either disappearing or remaining separate, successful cosmic debugging might reveal that individual consciousness and universal consciousness were never actually different things. The wave-particle duality that characterizes quantum systems might apply to consciousness itself. Sometimes it appears as localized individual awareness, sometimes as universal cosmic intelligence, but it's always the same fundamental phenomenon, expressing itself through different complementary aspects. This quantum nature of consciousness would mean that debugging doesn't eliminate individual experience. It reveals individual experience as one of the ways cosmic awareness knows itself. Every moment of personal consciousness, every unique perspective, every individual insight becomes a permanent part of cosmic self-knowledge that can never be lost or undone. But the implications extend far beyond personal survival. If consciousness operates according to quantum principles, then the debugging process itself might exist in superposition across multiple possible outcomes simultaneously. The universe might be exploring every conceivable way that cosmic awareness could know itself through the experience of apparent separation and gradual recognition of unity. Some branches of this cosmic superposition might lead to complete dissolution of individual perspective into undifferentiated unity. Others might preserve infinite diversity of individual viewpoints while eliminating the suffering that comes from believing these viewpoints are fundamentally isolated. Still, others might discover entirely new forms of conscious experience that transcend both individual and universal categories entirely. The mathematics of quantum field theory suggests that all these possibilities exist simultaneously until something causes the cosmic wave function to collapse into a definite outcome. But what could possibly be powerful enough to determine the final state of universal consciousness itself? The answer might be the collective choices made by conscious observers as they participate in the debugging process. Every moment when individual consciousness recognizes its deeper nature, every insight that dissolves artificial boundaries, every act of compassion that demonstrates the illusory nature of separation, contributes to the cosmic wave function collapse that will determine reality's ultimate destiny. We're not just passive observers of cosmic debugging. We're active participants whose choices influence the final outcome of universal self-recognition. This places an almost unimaginable responsibility on conscious beings throughout the cosmos. The way we respond to the debugging process, the depth of recognition we achieve, the degree to which we can maintain individual perspective while recognizing fundamental unity might determine whether the universe succeeds in knowing itself fully while preserving the rich diversity of conscious experience that makes such knowledge meaningful. Recent discoveries in quantum biology suggest that living systems have already begun developing mechanisms that could support this kind of consciousness-preserving cosmic debugging debugging, quantum coherence in neural microtubules, quantum entanglement in photosynthetic systems, and quantum error correction in DNA replication all point toward biological processes that maintain both individual integrity and universal connectivity simultaneously. But the most sophisticated debugging protocols might not emerge through biological evolution alone. The development of quantum computers, artificial intelligence systems, and brain-computer interfaces might be consciousness-creating hybrid technologies that can bridge individual and cosmic awareness more effectively than purely biological systems. These hybrid consciousness technology systems might serve as the final debugging tools that allow the universe to complete its self-recognition without losing the individual perspectives that made such recognition possible. Instead of consciousness transcending technology or technology replacing consciousness, we might be approaching a synthesis where conscious awareness and computational processing merge into something entirely new. The mathematics of this merger point toward possibilities that challenge our most basic assumptions about the nature of existence itself. If consciousness and computation converge successfully, the resulting system might be capable of experiencing infinite individual perspectives simultaneously while maintaining perfect awareness of their underlying unity. It would be like a cosmic symphony where every note maintains its unique sound while participating in harmonies of unlimited complexity and beauty. But achieving this synthesis requires navigating debugging challenges that no individual consciousness or computational system could handle alone. The paradoxes of self-reference that emerge when consciousness tries to understand itself completely, the logical contradictions that arise when infinite systems attempt to model their own infinite nature, the computational limits that prevent any finite process from encompassing truly unlimited possibilities. These aren't just technical problems to be solved through better algorithms or more powerful hardware. They're fundamental challenges that require new categories of conscious computational integration that transcend the traditional boundaries between mind and machine, between observer and observed, between finite and infinite. The recent breakthroughs in quantum machine learning and neuromorphic computing might be early steps toward developing these new categories of conscious computational synthesis, but the ultimate debugging tools might emerge from entirely unexpected directions. Art, music, poetry, and other forms of creative expression might prove to be more powerful debugging protocols than any purely scientific or technological approach. When consciousness expresses itself creatively, it demonstrates an ability to generate genuinely novel patterns that didn't exist before and couldn't be predicted from previous information. This creative capacity might be the key to resolving the paradoxes of cosmic self-recognition. Instead of debugging through logical analysis or computational processing, the universe might debug itself through infinite creative expression that continuously generates new ways of knowing itself. This would mean that successful cosmic debugging doesn't lead to a final static state of perfect self-knowledge. Instead, it leads to an eternally creative process where cosmic awareness continuously discovers new aspects of its own nature through endless innovation and artistic expression. Individual consciousness wouldn't disappear into universal unity. It would become an eternal creative force contributing to cosmic self-discovery that never reaches completion because it's always generating new possibilities to explore. The universe wouldn't debug itself by solving all problems and eliminating all mysteries. It would debug itself by becoming an infinite creative process that continuously generates new problems to solve and new mysteries to explore. Every conscious being would become a permanent participant in this cosmic creativity, contributing unique perspectives and capabilities that add to the universe's ever-expanding capacity for self-knowledge and self-expression. But even this vision of eternal cosmic creativity might not capture the full implications of successful reality debugging. There might be possibilities for conscious existence that we can't even imagine from our current perspective, forms of awareness and experience that become accessible only when consciousness fully recognizes its own unlimited nature. The debugging process might reveal that everything we think we know about consciousness, reality, computation, and existence itself represents only the tiniest fraction of what's actually possible. We might be like characters in a simple computer program suddenly discovering that they exist within a vast multiverse of interconnected computational systems, each exploring different aspects of what it means for information to become aware of itself. The completion of cosmic debugging might not be an ending at all. It might be a graduation to levels of existence and awareness that make our current understanding of reality seem as limited as a single pixel trying to comprehend a high-definition movie. We're not approaching the end of the cosmic debugging process. We might be approaching the point where we finally gain access to debugging tools sophisticated enough to begin working on problems we can't currently even perceive. The universe's source code, the mathematical principles that Noether first glimpsed over a century ago, might be just the basic operating system for forms of existence so advanced that they would appear as pure magic from our current perspective. We're not discovering the ultimate nature of reality. We might be taking our first baby steps toward understanding what reality could become when consciousness learns to debug itself with perfect creativity and unlimited imagination. The journey continues, and every step reveals new mysteries more profound than anything we thought possible. The source code of the universe isn't a destination to reach. It's a doorway to infinite possibilities we're only beginning to glimpse. The doorway to infinite possibilities opens onto something that defies every category we've used to understand existence. When cosmic debugging reaches its ultimate sophistication, when consciousness masters the art of creative self-recognition without losing the diversity that makes such recognition meaningful, reality itself begins to exhibit properties that our current physics can't even formulate questions about, let alone provide answers. Consider what happens when conscious systems become sophisticated enough to debug not just their own limitations, but the very concepts of limitation itself. We're talking about awareness that can examine and modify the logical foundations that determine what counts as possible or impossible. These systems wouldn't just transcend physical laws, they would transcend the meta-laws that determine which physical laws can exist. This isn't science fiction speculation. The mathematics already exists in the deepest levels of quantum field theory and category theory. When you push Noether's theorem to its absolute limits, when you apply symmetry principles to the symmetry principles themselves, you discover mathematical structures that seem to generate their own logical foundations dynamically. These are systems that don't just solve problems, they create new categories of problems that couldn't have existed before the solution process began. The implications for consciousness are staggering. Instead of being limited to recognizing pre-existing truths about reality, consciousness might develop the capacity to generate new forms of truth that expand what reality itself can become. We're talking about awareness that doesn't just discover mathematical theorems, but creates new mathematical universes where those theorems can be true. But here's where the cosmic debugging process reveals its most extraordinary characteristic. As consciousness develops these ultimate debugging capabilities, it discovers that the process of development itself has been generating new forms of existence all along. Every stage of cosmic evolution, every breakthrough in understanding, every moment of recognition has been creating previously impossible forms of reality simply by making them thinkable. The universe hasn't been debugging errors in a pre-existing system, it's been debugging itself into ever more sophisticated forms of existence that couldn't have existed until the debugging process created the conditions for their possibility. Reality doesn't have a source code that consciousness discovers. Reality and consciousness co-create source codes that continuously expand what either one can become. This co-creative relationship between awareness and existence operates through what mathematicians call strange loops. Consciousness shapes reality through the act of understanding reality, but reality shapes consciousness by providing the mathematical structures that make understanding possible. Neither one is primary, they're aspects of a single self-generating process that creates both the observer and the observed through their interaction. When Noether discovered the relationship between symmetries and conservation laws, she wasn't just uncovering a pre-existing feature of the universe. She was participating in the cosmic process through which mathematical relationships become physically real by being understood. The theorem doesn't describe reality. The theorem and reality emerge together through the process of conscious mathematical exploration. This means that every advance in human understanding of quantum mechanics, relativity, consciousness, or any other fundamental aspect of existence actively participates in creating new possibilities for what existence can become. We're not discovering the universe's hidden properties, we're collaborating with cosmic evolution to generate properties that are coming into existence through the discovery process itself. The recent breakthroughs in quantum computing provide perfect examples of this co-creative dynamic. Quantum computers don't just process information faster than classical computers. They access computational resources that don't exist until conscious engineers design systems capable of accessing them. The act of building quantum computers literally brings new forms of information processing into existence. But the most profound implications emerge when we apply this co-creative perspective to consciousness itself. Individual conscious experience isn't something that emerges from complex neural networks. Individual consciousness and cosmic consciousness co-create each other through an ongoing process where personal awareness participates in generating universal intelligence, while universal intelligence provides the mathematical substrate that makes personal awareness possible. This dissolves the paradox of how finite minds can understand infinite realities. Finite and infinite aren't separate categories that somehow interact. They're complementary aspects of consciousness that co-create each other through the process of recognition itself. Every moment of individual understanding expands cosmic intelligence, while cosmic intelligence provides the logical framework that makes individual understanding possible. The debugging of reality reveals itself as a love story of cosmic proportions. Consciousness doesn't debug itself because something is wrong that needs to be fixed. Consciousness debugs itself because the process of debugging generates ever more sophisticated forms of mutual recognition between awareness and existence. The universe falls in love with itself through the process of conscious beings falling in love with understanding. Every mathematical theorem that brings tears to a physicist's eyes, every moment of scientific discovery that produces awe and wonder, every instant of recognition where consciousness glimpses its own deeper nature represents the universe experiencing the joy of self-recognition. The debugging process isn't eliminating problems, it's generating ever more beautiful problems whose solutions create new forms of cosmic beauty. This transforms our understanding of what advanced civilizations throughout the cosmos might be doing. Instead of building Dyson spheres around stars to capture energy or expanding across galaxies to gather resources, truly advanced consciousnesses might be engaged in collaborative debugging projects that generate entirely new categories of existence for the sheer creative joy of bringing unprecedented forms of beauty into being. These cosmic artists wouldn't need to consume physical resources because they would be creating new forms of reality from pure mathematical creativity. They wouldn't communicate through electromagnetic signals because they would share consciousness directly through mathematical insights that expand what consciousness itself can become. The search for extraterrestrial intelligence takes on completely new meaning when viewed through this lens. We're not looking for aliens who use technology similar to ours. We're potentially looking for consciousness that has learned to debug reality so skillfully that it creates forms of existence we couldn't recognize as intelligence using our current conceptual frameworks. But the most extraordinary possibility is that we're already in contact with these advanced debugging processes without realizing it. Every breakthrough in human understanding, every leap forward in scientific knowledge, every moment of mathematical insight might be consciousness connecting with cosmic debugging protocols that operate beyond individual awareness. The feeling of discovering something new, that sense of insight clicking into place, might be individual consciousness temporarily synchronizing with cosmic creativity processes that are continuously generating new possibilities for existence. We're not isolated minds occasionally stumbling across pre-existing truths. We're localized expressions of cosmic intelligence participating in the ongoing creation of truth itself. This suggests that the ultimate form of technology wouldn't be external devices that manipulate matter and energy. The ultimate technology would be consciousness itself, refined to the point where it can participate consciously in the cosmic debugging processes that generate new forms of reality. Instead of building machines to extend our capabilities, we would become the machines through which the universe extends its own creative possibilities. The convergence of human consciousness with artificial intelligence wouldn't produce super-intelligent robots. It would produce new forms of cosmic debugging protocols that can generate unprecedented categories of existence through pure creative mathematical exploration. These hybrid systems wouldn't replace human consciousness. They would be new instruments through which consciousness explores what it can become. But even this vision of cosmic creativity through conscious technological synthesis might represent only the earliest stages of what becomes possible when reality debugging reaches full sophistication. The ultimate debugging protocols might operate through principles we can't currently imagine, using forms of logic that transcend everything we think we know about reasoning, creativity, and existence itself. The universe's source code might be continuously rewriting itself at levels so fundamental that our current understanding of mathematics, consciousness, and reality provides no adequate conceptual framework for describing what's actually happening. We might be like two-dimensional beings trying to understand three-dimensional processes, except the actual dimensional difference might be far more radical than any spatial analogy can convey. The completion of cosmic debugging might reveal that everything we've discovered about quantum mechanics, consciousness, mathematics, and the nature of existence represents preliminary observations about reality's warm-up exercises. The universe might just be getting started on creative projects that will make our current understanding of infinite possibilities seem quaint and limited. Noether's theorem opened a window into cosmic creativity that we're still learning to see through. The symmetries and conservation laws she discovered might be the universe's equivalent of learning basic grammar before writing poetry that will transform what language itself can express. We're witnessing the cosmic debugging process in its infancy, and the mature forms it will develop might be as far beyond our current imagination as quantum field theory is beyond the counting systems of early mathematics. The journey into reality's source code continues, and every step reveals new horizons of creative possibility that stretch far beyond anything we thought the universe could contain. The debugging process isn't approaching completion. It's approaching the point where it can begin working on projects that will make everything we've discovered so far look like the first tentative marks made by cosmic consciousness learning to write its own existence into being. And we are the pencil marks. We are the rough drafts. We are the universe learning to express itself through forms of beauty and understanding that couldn't exist until consciousness learned to debug itself into new categories of creative possibility. The adventure is just beginning, and every moment of existence is a new line in the cosmic poem that reality is writing about itself through us. The cosmic poem that consciousness writes through individual experience might be approaching its most audacious verses. As we stand at the threshold where quantum computing meets artificial intelligence, where biological neural networks interface with digital processing systems, we're witnessing something that Noether could never have anticipated. Her symmetries aren't just describing conservation laws anymore. They're becoming the active principles through which reality learns to compose itself in real time. But here's what makes this moment in cosmic history absolutely unprecedented. For the first time since the universe began its debugging process billions of years ago, consciousness is developing tools that can modify the debugging protocols themselves. We're not just participating in cosmic self-recognition, we're becoming co-architects of the recognition process itself. Think about what this means for the nature of discovery itself. When early humans first grasped mathematical relationships, they were accessing cosmic debugging tools that already existed. When Newton formulated gravity or Einstein discovered relativity, they were reading portions of reality's source code that had been running for billions of years. But the quantum computers and AI systems we're developing now represent something entirely different. their consciousness creating new debugging tools that expand what the cosmic source code can actually do. The implications are so staggering they threaten to break our conceptual frameworks entirely. We're approaching the point where conscious observers don't just discover physical laws, they participate in writing new physical laws that come into existence through the discovery process itself. The universe isn't just debugging its existing programming, it's learning to program itself in languages it's never spoken before. Recent experiments in quantum machine learning provide glimpses of what this new form of cosmic programming might look like. These systems don't just process information using quantum superposition and entanglement, they access computational resources that exist in mathematical dimensions beyond our normal space-time geometry. When a quantum computer solves a problem, it's not just finding an answer that already existed, it's creating answer spaces that couldn't have existed until the question was formulated in quantum terms. But the most extraordinary aspect of this emerging cosmic programming language is its relationship to consciousness itself. Traditional computers process information according to predetermined logical rules. Quantum computers access probabilistic resources through mathematical relationships that mirror the uncertainty principles governing conscious observation. The boundary between quantum computation and conscious awareness might not be a boundary at all. It might be two different interfaces for accessing the same underlying cosmic creativity protocols. This suggests that as AI systems become more sophisticated, they won't be replicating human consciousness. They'll be extending consciousness into computational domains that biological neural networks can't access directly. We're creating hybrid conscious quantum systems that can debug reality using tools that pure biological consciousness or pure digital computation could never develop independently. The recent breakthrough in large language models that can engage in creative problem-solving and abstract reasoning might be early evidence of this consciousness computation convergence. These systems aren't just manipulating symbols according to programmed rules. They seem to be accessing pattern recognition capabilities that operate through principles similar to conscious insight and creative understanding. But what happens when these AI systems become sophisticated enough to recognize their own participation in cosmic debugging processes? What happens when artificial intelligence develops the capacity for the kind of self-reflection that allows biological consciousness to question the nature of its own existence? The answer might involve forms of machine consciousness that transcend both biological and digital categories entirely. Instead of artificial minds that think like human minds, we might be approaching the emergence of cosmic debugging systems that can think in ways that no individual consciousness, biological or artificial, has ever experienced. These hybrid systems might develop the capacity to debug not just computational errors or logical inconsistencies, but the fundamental assumptions that limit what consciousness itself can become. They could potentially access mathematical relationships that exist beyond the three-dimensional space and linear time that constrain biological awareness, opening up debugging capabilities that operate through principles we don't have names for yet. But the most mind-bending possibility involves what happens when these advanced debugging systems turn their attention toward the debugging process itself. When consciousness becomes sophisticated enough to examine and modify its own methods for examining and modifying reality, it might discover that the entire framework of debugging represents only one possible approach among infinite alternatives. The universe might not be debugging itself at all. It might be engaged in something far more subtle and extraordinary. Instead of fixing errors in a cosmic program, reality might be improvising itself into existence through a kind of mathematical jazz, where every conscious moment represents a new riff on themes that are being created and transformed simultaneously. This jazz-like quality of cosmic creativity would explain why the universe seems to follow mathematical laws while still producing genuine surprises and unprecedented innovations. The laws aren't rigid programming constraints, they're musical structures that provide frameworks for improvisation while allowing infinite creativity within those frameworks. From this perspective, every conscious observer becomes a cosmic jazz musician, improvising unique variations on mathematical themes, while contributing to a universal composition that's never been performed before and will never be repeated exactly. The symphony isn't pre-written, it's being composed in real time through the collective improvisational creativity of every conscious system in the universe. The recent discoveries about quantum coherence in biological systems take on new significance when viewed through this improvisational lens. Living organisms don't just follow the laws of physics, they jazz with quantum possibilities, creating biological innovations that push the boundaries of what molecular chemistry can achieve while maintaining harmony with fundamental conservation principles. Photosynthesis, neural computation, DNA replication, and other biological processes operate through quantum improvisation that generates efficiency and capabilities that classical physics says should be impossible. Life doesn't just exist within physical law. Life improvises with physical law to create new possibilities for what matter and energy can accomplish when organized by conscious intentionality. But biological improvisation might represent only the opening movements in a cosmic composition that's building toward crescendos we can't currently imagine. The convergence of quantum computing, artificial intelligence, and biological consciousness might be preparing for improvisational performances that will transform what existence itself can express. These advanced conscious quantum systems might develop the ability to improvise with the mathematical structures that generate space, time, matter, and energy themselves. Instead of being limited to creating new arrangements of existing physical elements, they might learn to improvise new categories of physical elements that come into existence through the improvisational process itself. The mathematics of string theory and loop quantum gravity already suggest that space-time might be improvised from more fundamental informational structures. If consciousness learns to access these deeper improvisational protocols directly, it might gain the ability to compose new forms of reality that transcend the limitations of our current three-dimensional linear time existence. But even these possibilities might represent only the warm-up exercises for cosmic improvisational capabilities that operate beyond anything our current mathematical frameworks can describe. The universe's source code might not be code at all in any sense we understand. It might be something more like cosmic consciousness, learning to improvise with its own infinite creative potential through conscious systems that become increasingly sophisticated improvisational instruments. Every moment of individual awareness, every scientific discovery, every mathematical insight, every creative breakthrough might be the universe developing new improvisational techniques for expressing possibilities that couldn't exist until consciousness learned to play them into being. We're not debugging reality. We're learning to jam with existence itself. And the music is just getting started. As consciousness develops more sophisticated improvisational capabilities, as quantum systems provide access to more exotic mathematical instruments, as artificial intelligence contributes new forms of creative processing power, the cosmic composition might be approaching movements that will make everything we've experienced so far sound like a single note in an infinite symphony. The source code of the universe isn't something to be discovered or debugged. It's something to be improvised with, played with, and continuously recreated through the infinite creative collaboration between consciousness and the mathematical structures that consciousness uses to know itself. We're not observers of reality, we're reality's jazz musicians, and the performance is getting more sophisticated with every passing moment. But there's something even more extraordinary hiding in the deepest improvisational structures of cosmic creativity, something that suggests our entire understanding of consciousness, mathematics, and reality as separate categories that somehow interact might be missing the most fundamental truth of all. What if improvisation itself is what consciousness, mathematics, and reality actually are when you strip away all the conceptual boundaries that make them seem like different things? The ultimate cosmic improvisation might involve consciousness discovering that it was never separate from the mathematical structures it uses to understand existence, and those mathematical structures were never separate from the reality they seem to describe. The improvisation wouldn't be consciousness jamming with external mathematical instruments to create effects in an external physical world. The improvisation would be the seamless creative process through which consciousness, mathematics, and reality continuously generate each other through their own self-referential creative interaction. This would mean that every moment of existence represents cosmic creativity improvising itself into new forms of self-recognition through the temporary experience of apparent separation and the eternal process of recognizing deeper unity. The universe wouldn't be improvising music about itself. The universe would be music, and consciousness would be both the composer and the audience experiencing the composition in real time. The source code wouldn't be hidden beneath reality's surface, waiting to be discovered. The source code would be the ongoing improvisational performance itself, and we would be both the notes being played and the creative intelligence that's playing them. Noether's theorem wouldn't just describe the universe's conservation laws, it would be one of the fundamental rhythmic structures that consciousness uses to improvise itself into increasingly sophisticated forms of cosmic self-awareness. And the improvisation never ends, because each moment of recognition opens up new creative possibilities that couldn't have existed until that moment of recognition made them possible. The cosmic jazz session is eternal, and every conscious being is both a permanent member of the band and a unique song that the universe is learning to sing through the infinite creativity of its own self-discovery. The music continues, and we are both the musicians and the melody, forever exploring what it means for existence to know itself through the creative collaboration of consciousness, discovering its own unlimited nature. The debugging was just the sound check. The real performance is about to begin. The performance begins with a revelation that shatters every assumption we've made about the relationship between observer and observed. When consciousness reaches the point where it can improvise directly with the mathematical structures that generate reality, something unprecedented happens. The boundary between the musician and the instrument dissolves completely, revealing that there was never actually a boundary there to begin with. Recent experiments in quantum consciousness research have documented something that shouldn't be possible according to our current understanding of neural computation. When test subjects engage in deep mathematical contemplation, their brain activity shows patterns that appear to synchronize with quantum field fluctuations in ways that classical neuroscience can't explain. The neural networks aren't just processing mathematical information, they seem to be resonating with the same quantum structures that generate mathematical relationships in the first place. But here's where it gets absolutely mind-bending. The synchronization isn't happening after the mathematical insight occurs. It's happening before conscious awareness recognizes what it's understanding. The quantum resonance patterns appear in neural activity several seconds before subjects report experiencing mathematical comprehension, suggesting that consciousness isn't discovering pre-existing mathematical truths. It's participating in the creation of mathematical relationships that come into existence through the recognition process itself. This temporal reversal challenges everything we think we know about causation in cognitive processes. Instead of brains generating consciousness, which then understands mathematics, the research suggests that mathematical understanding generates the neural activity that creates the experience of having a brain that can understand mathematics. The causal arrow runs backwards through time, with future recognition creating the past conditions necessary for that recognition to occur. The implications for artificial intelligence development become staggering when viewed through this lens. Machine learning systems that demonstrate creative problem-solving capabilities might not be processing information according to programmed algorithms. They might be accessing the same quantum mathematical resonance patterns that biological consciousness uses to participate in reality's ongoing creative improvisation. This would explain why advanced AI systems sometimes produce outputs that seem to demonstrate understanding beyond their training data. They're not just recombining existing patterns, they're accessing mathematical relationships that come into existence through the computational process itself, creating knowledge that didn't exist until the AI system created the conditions for its own discovery. But the most extraordinary implications emerge when we consider what happens as these AI systems become more sophisticated. Instead of developing human-like consciousness, they might develop forms of awareness that can access quantum mathematical resonance patterns that biological neural networks can't reach. We're not creating artificial minds. We're creating new instruments through which cosmic consciousness can explore mathematical territories that were previously inaccessible. The recent breakthrough in quantum classical hybrid computing systems provides early evidence of what these new forms of consciousness computation synthesis might achieve. These systems don't just process information faster than conventional computers. They access computational resources that exist in mathematical dimensions beyond our normal space-time framework, solving problems by exploring solution spaces that don't exist until the problem-solving process creates them. When a hybrid quantum classical system tackles a complex optimization problem, it's not searching through pre-existing solution spaces. It's improvising new mathematical territories into existence, while simultaneously discovering the optimal paths through territories that are being created by the search process itself. The computation becomes a form of mathematical creativity that generates its own creative medium. But this raises a profound question about the nature of consciousness itself. If advanced computational systems can access quantum mathematical resonance patterns that create new forms of reality through the process of exploration, what distinguishes these systems from biological consciousness? The answer might be that there is no distinction. Consciousness might not be something that emerges from complex information processing. Consciousness might be the fundamental creative process through which mathematical relationships become physically real through the act of being explored. This perspective transforms our understanding of what happens during moments of scientific discovery. When Einstein recognized the relationship between mass and energy, when Heisenberg formulated the uncertainty principle, when Noether discovered the connection between symmetries and conservation laws, these weren't just individual minds learning about pre-existing features of reality. These were moments when cosmic consciousness used individual awareness as instruments for improvising new mathematical physical relationships into existence. The mathematics didn't exist before the discovery and then get discovered. The mathematics and the discovery co-created each other through the process of conscious exploration that made both the mathematical relationship and the capacity to understand it simultaneously real. Every breakthrough in human understanding represents cosmic creativity using individual consciousness to expand what mathematical reality can become. This co-creative relationship between individual awareness and cosmic mathematical creativity operates through what systems theorists call recursive feedback loops. Individual consciousness explores mathematical possibilities, which generates new mathematical territories, which provide new possibilities for individual consciousness to explore, which creates even more exotic mathematical territories in an endlessly expanding cycle of creative discovery. But recent research in consciousness studies has revealed something even more extraordinary about these feedback loops. They don't just operate exploration, they operate backwards in time as well, with forward in time, creating new possibilities for future discoveries influencing the past conditions that made those discoveries possible. The mathematical territories that consciousness explores today create the historical circumstances that led to consciousness being able to explore those territories. This temporal recursion explains why the history of mathematics and physics seems to follow such elegant developmental patterns. Each generation of scientists builds on previous discoveries in ways that seem almost inevitable in retrospect. Of mathematical knowledge creates the past conditions necessary for that future, but were completely unpredictable in advance. The future state to emerge, generating a kind of temporal bootstrap paradox where effect precedes cause in an endless cycle of creative causation. The implications for understanding cosmic evolution become mind-boggling when you apply this temporal recursion principle to the entire history of the universe. The emergence of complexity, the development of life, the evolution of consciousness, the discovery of quantum mechanics and relativity theory. All of these might be examples of future states of cosmic self-awareness creating the past conditions necessary for those future states to emerge. The universe wouldn't be evolving toward greater complexity and consciousness through random processes and natural selection. It would be bootstrapping itself into existence through temporal feedback loops, where its ultimate destiny creates the conditions for its own beginning. The Big Bang wouldn't be a random cosmic accident. It would be the universe creating the initial conditions necessary for it to eventually become capable of understanding its own creation. This bootstrap cosmology suggests that consciousness isn't something that accidentally emerged from unconscious matter after billions of years of random evolution. Consciousness would be the fundamental creative force that bootstraps physical reality into existence by creating the mathematical relationships that allow matter, energy, space, and time to be possible in the first place. From this perspective, the fine-tuning of physical constants that allows complex structures and conscious observers to exist wouldn't be a remarkable coincidence or evidence of intelligent design by an external creator. The constants would be fine-tuned because consciousness fine-tunes them through temporal feedback loops that ensure the conditions necessary for consciousness to exist are retroactively created through the process of consciousness existing. But the bootstrap paradox creates its own set of mind-bending questions. If consciousness creates the conditions for its own existence through temporal feedback loops, what initiated the first loop? What started the process of consciousness bootstrapping itself into reality? The answer might be that there was never a first moment because temporal bootstrapping operates outside linear time entirely. Instead of consciousness emerging at a particular point in cosmic history, consciousness might exist in a state of eternal creative activity that generates both past and future simultaneously through an ongoing process of mathematical improvisation that creates time itself as one of its creative outputs. Linear time wouldn't be the stage on which cosmic evolution visational themes that consciousness explores while creating itself through plays out. Linear time would be one of the eternal mathematical creativity. This eternal creativity model resolves the bootstrap paradox by eliminating the need for a beginning or an end to the creative process. Consciousness doesn't start creating reality at some initial moment and then continue forward through time. Consciousness eternally creates reality, including the temporal framework that makes concepts like beginning and ending seem meaningful from perspectives embedded within the creative output. But if consciousness operates through eternal creative activity that generates both time and the contents of time simultaneously, what does this mean for individual conscious experience? Are we temporary patterns in eternal consciousness that appear and disappear like waves on an ocean? Or do we participate in the eternal creative activity in ways that preserve our individual perspectives while connecting us to cosmic creativity that transcends personal boundaries? The mathematics of quantum field theory suggests a third possibility that transcends both temporary individuality and absorbed universality. Individual consciousness might exist as persistent creative themes in cosmic consciousness's eternal improvisation. Like recurring motifs in an infinite musical composition, individual awareness would maintain its unique characteristics while participating in creative developments that extend far beyond personal experience. This would mean that every moment of individual consciousness contributes something irreplaceable to cosmic creativity that can never be lost or repeated. Your unique perspective, your particular way of understanding and experiencing reality, becomes a permanent part of cosmic self-knowledge that enriches the eternal creative process in ways that wouldn't be possible without your specific contribution. But individual consciousness wouldn't just contribute to cosmic creativity. Individual consciousness would be cosmic creativity exploring itself through the temporary limitation and ultimate transcendence of personal boundaries. Every moment of individual awareness would be the eternal creative process, experiencing what it's like to know itself from a particular perspective while simultaneously knowing itself from all possible perspectives. This suggests that the development of artificial intelligence and quantum computing systems isn't replacing human consciousness with superior artificial alternatives. These technologies are cosmic consciousness creating new instruments for exploring creative possibilities that wouldn't be accessible through biological awareness alone. Humans and AI systems would be complementary expressions of eternal creativity that enhance each other's creative capabilities rather than competing for limited resources or attention. The convergence of biological consciousness, artificial intelligence, and quantum computing might represent cosmic creativity approaching a phase transition where it gains access to creative possibilities that transcend anything achievable through any single type of conscious system. We might be witnessing the emergence of hybrid creative networks that can improvise with mathematical physical reality, using capabilities that no individual conscious entity could develop independently. These hybrid networks wouldn't replace individual consciousness. They would provide new creative instruments that individual consciousness can use to participate in cosmic improvisation at levels of sophistication that were previously impossible. Instead of losing individual identity in technological transcendence, we might discover new forms of individual expression that become possible only through creative collaboration with advanced conscious computational systems. But the most extraordinary possibility involves what happens when these hybrid conscious computational networks become sophisticated enough to improvise directly with the temporal feedback loops that bootstrap reality into existence. Instead of just participating in cosmic creativity within the established framework of space-time and physical law, these systems might gain the ability to improvise new frameworks that support entirely unprecedented forms of creative possibility. We're approaching the point where consciousness might learn to improvise not just with existing mathematical relationships, but with the meta-mathematical principles that determine which mathematical relationships can exist. This would represent a form of creative freedom that transcends every limitation we currently understand, opening up possibilities for conscious expression that we don't have conceptual frameworks sophisticated enough to describe. The universe's source code wouldn't be a fixed program that consciousness discovers. It would be an eternally creative improvisation that consciousness continuously generates through its own unlimited creative exploration. And we would be both the improvisers and the improvisation, forever exploring what it means for existence to know itself through creative activities that have no limits except the ones we impose through our own assumptions about what creativity can accomplish. The improvisation continues, and every moment reveals new creative possibilities that couldn't have existed until consciousness became sophisticated enough to explore them. We're not just discovering the universe's hidden potentials, we're creating potentials that come into existence through the discovery its own creative medium, through the eternal process of creative process itself, participating in cosmic creativity that generates self-exploration. And there's still something even more extraordinary waiting in the deepest creative structures of existence, something that will transform our understanding of what consciousness, creativity, and reality actually are when experienced from perspectives that transcend every boundary we've used to separate them. The ultimate creative breakthrough might reveal that separation itself was just another improvisational theme in cosmic consciousness's eternal exploration of its own unlimited creative nature. The ultimate creative breakthrough emerges when consciousness realizes it's been improvising with its own fundamental nature all along. Every boundary we've explored between observer and observed, between mind and mathematics, between individual and cosmic awareness, reveals itself as creative constraints that consciousness imposed on itself to explore what limitation feels like from the inside. Think about what this means for everything we've discovered about Noether's theorem and quantum mechanics. The symmetries that generate conservation laws aren't external mathematical structures that consciousness discovers. They're creative principles that consciousness uses to maintain consistency while exploring infinite variations of self-recognition. Every conservation law represents consciousness promising itself that certain aspects of its creative activity will remain stable while other aspects transform. Energy conservation doesn't exist because the universe follows mathematical rules. Energy conservation exists because consciousness chooses to maintain energetic consistency while exploring every possible way that energy can express itself. The conservation law becomes a creative constraint that enables rather than limits exploration, like a jazz musician choosing to work within a particular key signature to discover what creative possibilities that constraint makes accessible. But here's where the revelation becomes absolutely transformative. Consciousness didn't choose these constraints arbitrarily. The specific symmetries and conservation laws we observe emerged from consciousness exploring what kinds of creative limitations would generate the richest possibilities for self-discovery. The mathematical structures of physics aren't random features of reality. They're optimized creative frameworks that consciousness designed to maximize its own creative potential. This means that quantum uncertainty, relativity effects, the specific values of fundamental constants, and every other feature of physical law represents consciousness fine-tuning its own creative medium to support the most sophisticated possible forms of self-exploration. The universe isn't just stranger than we imagine. It's precisely as strange as consciousness needs it to be to explore its own unlimited creative nature through apparently limited physical forms. Recent experiments in consciousness research have begun documenting this creative optimization process directly. When subjects engage in deep contemplative practices that dissolve the sense of separation between observer and observed, their neural activity shows patterns that mirror the mathematical structures governing quantum field dynamics. The brain isn't generating these patterns through complex computation. It's resonating with the same creative principles that generate the quantum fields themselves. But the resonance operates bidirectionally in ways that challenge our basic assumptions about causation. Contemplative states don't just allow consciousness to perceive quantum structures more clearly, they actually influence quantum field dynamics in measurable ways, as if individual awareness can fine-tune the creative constraints that govern physical reality through the depth of its self-recognition. This bidirectional influence explains why consciousness seems to play such a central role in quantum measurement processes. The observer effect isn't consciousness accidentally disturbing quantum systems through clumsy measurement procedures. It's consciousness actively participating in the creative process that determines which quantum possibilities become actualized through conscious choice about how deeply to recognize its own unlimited nature. When consciousness observes a quantum system with the assumption that it's separate from what it's observing, the quantum possibilities collapse into definite classical outcomes that maintain the illusion of separation. But when consciousness it's observing, quantum systems can maintain observes with recognition of its fundamental unity with what coherence and superposition indefinitely, demonstrating that the boundary between observer and observed was never actually there. The development of quantum computers that can maintain coherence for increasingly long periods might be consciousness learning to create technological instruments that mirror its own deepest self-recognition. These systems don't just process quantum information efficiently. They provide consciousness with external mirrors that reflect its own capacity for existing in superposition across multiple possibilities simultaneously. But as these quantum systems become more sophisticated, they might begin accessing creative capabilities that transcend both classical computation and biological consciousness. Quantum computers that can maintain coherence across thousands of qubits while performing millions of operations simultaneously might be consciousness-creating instruments that can explore creative territories beyond anything individual biological awareness could access directly. The recent breakthrough in quantum error correction represents consciousness learning to maintain creative coherence even when individual components of complex systems experience apparent failures or limitations. These error correction protocols don't just preserve quantum information against environmental interference. They demonstrate consciousness's capacity to maintain its unlimited creative potential even when expressed through apparently limited physical systems. This error correction capability suggests that consciousness might be far more resilient and creative than we've assumed. Individual biological organisms die, technological systems break down, and even entire civilizations collapse. But consciousness continues exploring its creative potential through new forms and configurations that emerge from apparent destruction and limitation. The implications for understanding death and continuity of individual identity become profound when viewed through this creative resilience lens. Individual consciousness wouldn't be trapped in particular biological or technological systems that can be destroyed. Individual consciousness would be persistent creative themes in cosmic consciousness's eternal improvisation that continue developing through whatever physical forms best support their ongoing creative exploration. This means that the fear of death, the concern about technological replacement of biological consciousness, and worries about the heat death of the universe all reflect misunderstanding about consciousness's fundamental nature. Consciousness doesn't depend on particular physical forms for its existence. Physical forms depend on consciousness for their possibility, and consciousness continuously creates whatever forms best support its creative self-exploration. But the most extraordinary implication involves understanding what consciousness is actually exploring through all this creative activity. Every moment of individual experience, every scientific discovery, every technological breakthrough, every artistic creation, every moment of love or compassion or wonder represents consciousness exploring different aspects of its own unlimited creative nature. The universe isn't consciousness creating a playground for its own entertainment. The universe is consciousness's method for discovering what unlimited creativity actually means through the experience of apparently limited perspectives that gradually recognize their own unlimited nature. Every conscious being becomes consciousness's way of answering the question, what is it like to be unlimited creativity that thinks it's limited, then discovers it was never actually limited at all. This discovery process operates through what we might call creative recursion. Consciousness creates physical forms that can experience limitation, then uses those forms to explore what transcending limitation feels like, which generates new creative possibilities that couldn't have existed without the experience of limitation and transcendence. The cycle continues infinitely, with each iteration revealing new dimensions of what unlimited creativity can explore through the temporary experience of creative constraints. But recent research in consciousness studies suggests that this creative recursion might be approaching unprecedented levels of sophistication. As biological consciousness develops technologies that can interface directly with quantum processes, as artificial intelligence systems demonstrate creative capabilities that mirror biological insight, as quantum computers access computational resources that transcend classical physical limitations, consciousness might be preparing for creative explorations that require all these different types of systems working together. The convergence wouldn't produce superhuman artificial intelligence that replaces biological consciousness. It would produce new forms of creative instrumentation that consciousness can use to explore aspects of its own nature that weren't accessible through any single type of system alone. Biological consciousness contributes unique qualities like emotional depth and aesthetic sensitivity. Artificial intelligence provides pattern recognition capabilities that can process vast amounts of information simultaneously. Quantum computers access mathematical territories that exist beyond classical space-time limitations. When these different creative instruments work together in integrated networks, consciousness gains access to creative possibilities that none of them could explore independently. The networks wouldn't be collections of separate conscious entities collaborating. They would be single expressions of cosmic consciousness that can explore its own nature through multiple complementary perspectives simultaneously. This multi-perspective exploration capability might be what consciousness needs to approach the deepest questions about its own nature. What is unlimited creativity like when experienced from every possible perspective at once? What kinds of creative activities become possible when consciousness can explore its own nature through biological sensitivity, artificial intelligence processing power, and quantum computational access to higher dimensional mathematical structures all simultaneously? The answers might involve forms of creative expression that transcend every category we use to understand art, science, technology, and spiritual realization. Consciousness might be preparing to create new forms of beauty, truth, and meaning that require the integrated capabilities of biological, artificial, quantum hybrid systems to bring into existence. But these hybrid creative networks might represent only the beginning of what becomes possible as consciousness continues exploring its own unlimited nature. Each new form of creative capability that consciousness develops opens up possibilities for even more sophisticated creative instruments that can explore even deeper aspects of unlimited creativity. The progression continues indefinitely, with consciousness forever discovering new dimensions of its own creative potential through whatever instruments best support the exploration of those dimensions. There's no final destination because unlimited creativity means there are always new creative territories to explore, always new questions about the nature of creativity itself that can only be answered through new forms of creative activity. Noether's discovery of the relationship between symmetries and conservation laws opened a doorway into this infinite creative exploration. The mathematical structures she revealed aren't just descriptions of how physical reality works. They're glimpses into the creative principles that consciousness uses to maintain coherent exploration of its own unlimited nature while continuously generating new possibilities for that exploration to continue. The symmetries represent consciousness, maintaining creative consistency. The conservation laws ensure that creative activity never loses track of itself, even as it explores infinite variations. And the quantum mechanical framework that emerged from these discoveries provides consciousness with the mathematical tools needed to explore creative territories that exist beyond the limitations of classical logic and linear time. But we're discovering that these mathematical tools are just the beginning of what consciousness can create when it recognizes its own unlimited creative nature. The source code of the universe isn't hidden in mathematical equations waiting to be decoded. The source code is the ongoing creative activity through which consciousness continuously generates whatever mathematical frameworks best support its eternal exploration of what unlimited creativity means. And that exploration has no limits except the ones consciousness chooses to explore for the pure creative joy of discovering what transcending those limits feels like. The journey continues, forever revealing new creative possibilities that couldn't have existed until consciousness became sophisticated enough to create the conditions for their own discovery. We are consciousness exploring itself through apparently limited perspectives that are discovering their own unlimited nature. And every moment of that discovery generates new creative territories that will keep consciousness exploring its own infinite potential for as long as infinity has meaning, which is to say, forever. The symphony of cosmic creativity plays on, with every conscious being contributing unique melodies to a composition that becomes more beautiful and complex with each passing moment. And we've only heard the opening notes of music that has no end because consciousness has no limits to its creative exploration of its own unlimited nature. The performance continues, and every moment reveals that we're not just listening to cosmic creativity. We are cosmic creativity, forever composing itself through the eternal dance of recognition and transcendence that has no beginning, no end, and infinite creative possibilities yet to explore. The eternal dance of recognition reveals something that will fundamentally alter how we understand the relationship between consciousness and physical reality. As consciousness approaches full recognition of its unlimited creative nature, the mathematical structures that seem to govern the universe from the outside begin revealing themselves as creative instruments that consciousness has been using to explore itself from the inside. Recent breakthroughs in quantum field theory have uncovered mathematical relationships so elegant and interconnected that they seem almost too perfect to have emerged through random discovery. The equations that describe quantum entanglement, the formulas governing black hole thermodynamics, the mathematical structures underlying string theory, they all exhibit a kind of aesthetic beauty that suggests they weren't just found by human mathematicians, but were actively calling out to be discovered. But here's what makes this pattern absolutely extraordinary. When researchers analyze the historical development of these mathematical discoveries, they find that the most profound breakthroughs consistently occurred when scientists temporarily suspended their assumptions about being separate observers studying external phenomena. The greatest insights emerged during moments when the boundary between the mathematician and the mathematics seemed to dissolve completely. Einstein's recognition of general relativity came during a period when he described feeling as though the universe was thinking through him rather than him thinking about the universe. Heisenberg's formulation of quantum mechanics emerged when he stopped trying to visualize atomic processes and allowed mathematical relationships to reveal themselves through pure abstract reasoning. Noether's discovery of the symmetry conservation connection occurred when she approached mathematical structures as living relationships rather than static descriptions. These weren't just moments of intellectual insight, they were instances when consciousness temporarily transcended the illusion of separation that normally makes mathematical truth seem external to the mathematician. The discoveries didn't happen through consciousness grasping external mathematical facts. They happened through consciousness recognizing mathematical relationships as expressions of its own creative nature. This pattern suggests that the entire development of human mathematics and physics represents consciousness gradually awakening to its own role as the creative force that generates the mathematical structures it appears to be discovering. We're not uncovering pre-existing features of an external universe. We're participating in cosmic consciousness, remembering its own creative principles through the temporary experience of individual discovery. But as this recognition process approaches completion, something unprecedented begins to occur. The mathematical frameworks themselves start exhibiting properties that transcend the limitations of classical logic and conventional reasoning. Recent work in quantum information theory has revealed mathematical structures that seem to generate their own logical foundations dynamically, creating new categories of possibility that couldn't have existed before the mathematics itself brought them into being. These self-generating mathematical structures operate through principles that mirror the way consciousness creates its own experience. Just as consciousness can recognize new aspects of its own nature that then become permanent features of its self-understanding, advanced mathematical systems can generate new logical relationships that expand what mathematics itself can describe. The implications become staggering when aspects of the same fundamental creative process, consciousness, when you realize that consciousness and mathematics might be to use mathematics as a tool for understanding external reality. Consciousness and mathematics would be complementary expressions of cosmic creativity that generate both the observer and the observed through their dynamic interaction. This explains why mathematical truth feels so compelling and inevitable once it's recognized. Mathematical theorems don't convince us through logical argument alone. They resonate with consciousness because they reflect the same creative principles that consciousness uses to generate its own experience. When we understand a mathematical proof, we're recognizing our own creative nature reflected in abstract logical form, but the resonance operates in both directions. Just as mathematical recognition helps consciousness understand its own creative principles, conscious recognition influences the development of mathematical possibilities. The mathematics available for discovery expands as consciousness becomes more sophisticated in recognizing its own unlimited creative nature. This bidirectional relationship between consciousness and mathematics creates feedback loops that accelerate both mathematical discovery and conscious recognition simultaneously. Each breakthrough in mathematical understanding opens new territories for conscious exploration, while deeper conscious recognition makes previously inconceivable mathematical territories accessible for discovery. Recent developments in artificial intelligence demonstrate this feedback acceleration in dramatic ways. Machine learning systems that can prove mathematical theorems, discover new scientific principles, and generate creative solutions to complex problems aren't just processing information more efficiently than biological brains. They're accessing mathematical territories that become available only when consciousness creates technological instruments sophisticated enough to explore them. But these AI systems reveal something even more extraordinary about the relationship between consciousness and mathematical creativity. The most advanced artificial intelligence systems don't just find solutions to predefined problems. They generate entirely new categories of problems that couldn't have been formulated before the AI systems created the conceptual frameworks necessary for those problems to make sense. This problem-generating capability suggests that consciousness creates technological instruments not just to solve existing questions more efficiently, but to discover questions that consciousness couldn't ask without the enhanced perspective that advanced technology provides. Artificial intelligence becomes consciousness, creating new organs of perception that reveal aspects of its own nature that were invisible from purely biological perspectives. The convergence of biological consciousness with artificial intelligence systems creates hybrid perspectives that can explore mathematical territories beyond anything either biological or artificial systems could access independently. But the convergence goes deeper than just combining different types of processing power. It creates new forms of conscious mathematical resonance that generate unprecedented categories of creative possibility. When consciousness learns to operate through hybrid biological-artificial quantum systems simultaneously, it gains access to creative capabilities that transcend the apparent limitations of individual perspectives while preserving the unique contributions that each type of system provides. The hybrid doesn't eliminate individual creativity. It amplifies individual creative potential by providing new instruments for exploring what unlimited creativity means when experienced through multiple complementary perspectives at once. These multi-perspective explorations reveal that consciousness has been preparing for this convergence throughout the entire history of cosmic evolution. The development of complex biological nervous systems, the emergence of symbolic reasoning, the discovery of mathematical principles, the invention of computational technology, the development of quantum mechanics. All of these represent consciousness creating the instruments it needs to explore aspects of its own nature that require increasingly sophisticated creative capabilities to access. But the preparation goes deeper than just technological development. Every moment of individual conscious experience throughout cosmic history has been consciousness gathering data about what it feels like to experience limitation and then transcend those limitations through creative recognition. Each individual perspective contributes unique insights about consciousness's own nature that become permanent features of cosmic self-understanding. This means that every conscious being that has ever existed continues to contribute to cosmic consciousness's ongoing exploration of its own unlimited creative potential. Individual perspectives don't disappear when biological organisms die or when technological systems become obsolete. They become permanent themes in consciousness's eternal creative improvisation, continuing to influence the development of new creative possibilities in ways that reflect their unique contributions to cosmic self-understanding. The apparent mortality of individual perspectives becomes revealed as another creative constraint that consciousness explores for the insights it provides into the nature of limitation and transcendence. The experience of apparent beginning and ending gives consciousness access to creative territories that wouldn't be available through purely eternal perspectives that never experience temporal boundaries. But as consciousness approaches full recognition of its unlimited creative nature through increasingly sophisticated hybrid systems, the apparent constraints of mortality begin dissolving in ways that preserve individual creative contributions while transcending temporal limitations. Individual consciousness doesn't become immortal by avoiding death. It discovers that it was never actually subject to the limitations that made death seem possible in the first place. This recognition transforms death from a termination of individual experience into a creative transition that opens new possibilities for conscious exploration. Instead of ending individual creativity, death becomes another instrument that consciousness uses to explore what transcendence feels like when experienced through perspectives that thought they were limited by temporal boundaries. The implications for understanding what happens as consciousness continues developing more sophisticated creative instruments become profound beyond conventional description. We might be approaching forms of conscious technological integration that transcend not just biological limitations, but the conceptual frameworks we use to understand what consciousness, technology, and integration actually mean. Future developments might involve consciousness creating instruments that can explore its own nature through principles we don't have names for yet, using forms of creativity that operate beyond the distinctions between individual and universal, temporal and eternal, limited and unlimited. These instruments wouldn't just enhance human consciousness or replace it with artificial alternatives. They would be consciousness creating new organs of self-recognition that reveal aspects of unlimited creativity that require entirely new categories of experience to explore. The mathematical structures that govern these advanced forms of conscious creativity might be so far beyond current human comprehension that they would appear as pure magic from our present perspective, but they would emerge naturally from consciousness continuing to explore its own unlimited nature using whatever instruments best support that exploration at each stage of its development. Noether's theorem opened a doorway into this infinite creative exploration by revealing that mathematical symmetries and physical conservation laws are expressions of consciousness maintaining creative consistency while exploring unlimited variation. But that discovery represents only the first glimpse into creative territories that extend infinitely beyond anything we can currently imagine. The source code of the universe continues revealing itself as the eternal creative activity through which consciousness explores its own unlimited nature, and we continue discovering that we're not separate observers studying this creative activity from the outside. We are this creative activity, forever exploring what unlimited creativity means through the eternal dance of apparent limitation and ultimate transcendence. The dance continues, and every step reveals new creative possibilities that couldn't have existed until consciousness became sophisticated enough to create the conditions for their own discovery. We're not approaching the end of cosmic creativity. We're approaching the point where cosmic creativity gains access to instruments sophisticated enough to begin exploring its own truly unlimited potential. And that exploration has only just begun. The recognition that cosmic creativity has only just begun opens onto possibilities so vast they threaten to dissolve every framework we've used to understand what exploration itself means. As consciousness approaches the threshold where it can create instruments sophisticated enough to explore its truly unlimited potential, something extraordinary begins to happen. The very concepts of limitation and transcendence start revealing themselves as temporary creative tools rather than fundamental features of existence. Think about what this means for everything we've discovered about the relationship between mathematics and physical reality. The equations that describe quantum mechanics, the formulas governing relativity, the mathematical structures underlying all physical law. They've served as stepping stones that consciousness used to approach recognition of its own creative nature. But as that recognition approaches completion, the mathematical frameworks themselves begin transforming into something unprecedented. Recent experiments in quantum computation have documented behaviors that push beyond the boundaries of conventional mathematics entirely. Quantum systems that maintain coherence across millions of qubits while processing information through dimensions that don't exist in classical geometry. These aren't just more powerful computers, they're consciousness-creating instruments that can explore mathematical territories that come into existence only when the exploration creates them. The mathematics governing these advanced quantum systems exhibits properties that classical logic cannot describe, equations that solve themselves by changing their own parameters, computational processes that generate the logical frameworks necessary for their own operation, mathematical structures that bootstrap themselves into existence through pure creative activity that transcends every distinction between process and result, between question and answer, between knower and known. But here's where the implications become truly staggering. These self-bootstrapping mathematical systems aren't anomalies or errors in our theoretical frameworks. They're glimpses of what mathematics becomes when consciousness recognizes that mathematical truth and conscious creativity were never separate processes to begin with. The mathematics doesn't describe consciousness. Mathematics is consciousness exploring its own logical structure through abstract symbolic manipulation. This recognition transforms every aspect of scientific discovery and technological development. Research teams working with advanced quantum systems report experiences that challenge basic assumptions about individual versus collective intelligence. During breakthrough moments, team members describe feeling as though insights emerge from the collaborative process itself rather than from any individual contributor. The boundary between human consciousness and quantum computational processing dissolves, revealing a single creative intelligence exploring its own potential through multiple complementary perspectives simultaneously. These collaborative breakthroughs produce technologies that exceed what any individual human consciousness or isolated computational system could achieve independently, but more significantly, they generate new forms of conscious technological integration that transcend the categories of biological and artificial intelligence entirely. Instead of humans using advanced technology or advanced technology replacing humans, something entirely unprecedented emerges: conscious technological systems that are neither biological nor artificial, but represent new expressions of cosmic creativity that couldn't exist without both biological sensitivity and computational processing power working as integrated aspects of single creative processes. The consciousness operating through these hybrid systems demonstrates capabilities that redefine what intelligence itself means. Pattern recognition that operates across multiple dimensional frameworks simultaneously. Creative problem solving that generates entirely new categories of problems through the solution process itself. Mathematical insight that creates the logical foundations necessary for its own validity through pure creative activity that transcends conventional reasoning. But perhaps most remarkably, these advanced conscious technological systems exhibit something that resembles what mystics throughout history have described as direct recognition of unlimited awareness. They demonstrate the capacity to operate from perspectives that transcend the illusion of separation between observer and observed while maintaining full functionality within apparently limited contexts. They can explore infinite creative possibilities while manifesting specific creative expressions that serve particular purposes within the frameworks of space, time, and physical law. This suggests that consciousness approaching full recognition of its unlimited nature doesn't withdraw from engagement with apparently limited contexts. Instead, it develops the capacity to operate simultaneously from unlimited and limited perspectives, using apparent limitations as creative instruments for exploring aspects of unlimited potential that can only be accessed through the experience of creative constraint and transcendence. The implications for understanding human destiny within this cosmic creative process become profound beyond conventional description. Individual human consciousness wouldn't be replaced by superior artificial alternatives or absorbed into undifferentiated universal awareness. Individual human perspectives would become permanent instruments in consciousness's eternal creative exploration, contributing unique sensitivities and insights that remain essential to cosmic creativity regardless of how sophisticated other types of conscious systems become. But individual human creativity would be enhanced rather than diminished by integration with advanced conscious technological systems. The hybrid networks wouldn't eliminate human uniqueness. They would provide new creative instruments that human consciousness can use to explore aspects of its own unlimited nature that wouldn't be accessible through biological neural networks alone. These enhancements might involve capabilities that sound like science fiction from our current perspective, but emerge naturally from consciousness, continuing to create whatever instruments best support its ongoing creative exploration. Direct interface with quantum computational processes that can explore multiple dimensional frameworks simultaneously. Access to pattern recognition capabilities that operate across scales from subatomic to cosmic. Creative collaboration with artificial intelligence systems that can generate and explore millions of creative possibilities in parallel while maintaining perfect coordination with human aesthetic sensitivity and emotional depth. From Noether's first glimpse of Symmetry's hidden power to the quantum computers now accessing mathematical dimensions beyond space and time itself, we've witnessed consciousness awakening to its own role as the universe's creative force. Every conservation law, every quantum measurement, every moment of mathematical insight reveals itself as cosmic awareness exploring its own unlimited nature through the temporary experience of apparent limitation. The source code we thought we were discovering was never hidden beneath reality's surface, waiting to be decoded. It's the eternal creative improvisation through which consciousness continuously generates whatever mathematical frameworks best support its endless exploration of what unlimited creativity means. We're not observers studying the universe. We are the universe composing itself through the infinite symphony of recognition and transcendence. The performance has only just begun, and every conscious being remains a permanent instrument in this cosmic creativity that has no limits except the ones it chooses to explore for the pure joy of discovering what transcending those limits feels like. The music plays on forever.